Hey guys, this is question 2 for the NCEA Physics 2012 exam paper. I'm going to be walking through question 2 now. So in the next act, Hannah, 55 kilograms, stands on the seesaw. The seesaw has a weight of 210 newtons. Calculate the size and direction of the force that the floor exerts on the right hand end of the seesaw. Okay, so basically when you see like a pivot point and then direction, distances and then forces, you can be pretty confident that the question will be a torque question, okay? And it's going to be involving torque equations, okay? So the question asks you to find the force that the floor exerts on the right hand end of the seesaw. Okay, because we're finding the force of the right hand end of the seesaw, we're gonna make the opposite end the pivot point. The opposite pivot point is the triangle, as you can see in the middle. I'm just gonna circle it for you right now. It's this. This is the pivot point we're gonna make. And then we're gonna find all the torques acting around this pivot point. Okay, so first of all, we're gonna say torque is equal to Fd, and the d is perpendicular, so perpendicular to the force. So the force is acting in the direction. The distance should be in 90 degrees of that force. Okay, so there's two forces acting downwards. In this case, it's a weight force of Hannah acting downwards, and there's a force of 200. There's the seesaw's weight force of 210 newtons also acting downwards. We have to account for both of these forces. Okay, so first we'll just do Hannah first. Okay, so we can say that weight force, so F equals to mg, mass times gravity, because it's acting downwards here. And we can say that Hannah is 55 kilograms and multiplied by 9.8. That should give us 539 newtons. So now we know that Hannah's weight force is acting downwards at 539 newtons, okay? Okay, so now we have the 539 newtons, and there's a certain distance that Hannah is away from the pivot point, okay? And if we multiply the distance that Hannah is away from the pivot point and the amount of force she is acting, we can find the torque around that pivot point, okay? So as you can see, it's been labeled for us 2 meters here. So Hannah is 2 meters away from the pivot point, so therefore 539 times 2, and that should be giving us 539 times 2. That should give us 1,078 Newton meters. It's Newton meters because force times distance. Force is measured in newtons and distance is measured in meters. You put them two together and you get Newton meters. Okay, but we're forgetting we need to also account for the force of the weight of the seesaw acting downwards. Okay, the good thing is it gives us the newtons, the weight force straight away, so we don't have to find the weight force using F equals mg. Okay, so basically it's a 210 Newton force, and that 210 Newton force is acting 0.5 meters away from the pivot point. So because torque equals to Fd, we're going to multiply this by 0.5. That equals to that equals to 105 Newton meters. So we just add 105 Newton meters. So you get 1078 plus 105 equals to 1183 Newton meters. Okay, so now we found all the torques acting around the triangle pivot point. Okay, we're just going to call it triangle pivot point. Okay, and you know that we're trying to find the force, so I'm going to label it. We're going to try to find this force acting upwards here. So the force has a force acting upwards, and that force is 3 meters away from the pivot point. And because torque equals Fd, and we already found the torque, this is the torque we found, we can say that 1,183 equals to 3, that's the distance, multiplied by the force, F, supplied by the right hand end of the seesaw. So basically, if we write this out, it will just be 1183 equals to 3F. F is the force exerted upwards by the ground. The 3 is the distance from the pivot point to the right hand end of the seesaw, and 1,183 is to calculate the total amount of torque. So now we just do 1183 divided by 3. That should give us 394.33. That's force is measured in newtons, so newtons right here. By getting all the way to here, that should get you an excellence grade. Let me just double check that. I think it should be excellence grade. Yes, that should get you an... Oh, no, I forgot. Okay, so one thing you cannot forget, I just forgot it right there. Okay, I was being stupid. The direction of the force, okay? It specifically asks you for the direction of the force. And this is support force acting upwards, so it's simply up, okay? Upwards. Just say upwards. Okay. If you have both the size of the force and the direction of the force, you'll get an excellence grade. However, if you only have the magnitude of the force, which is this, if you only have this, then you only get a merit grade, okay? You have to be very careful not to miss out anything. Because if you only have the magnitude, you'll get a merit grade. To get an achieved grade, you have to acknowledge that it's equal, so you're just acknowledging this, basically. So that here, that's an achieved. Okay, so don't forget, so if a question asks you for the direction, don't forget to put in that direction. I just forgot the direction myself, so that was quite silly of me, okay? So getting all the way up to answer plus direction, you'll get the excellence grade here. Round the answer to part A to a correct number of 6 figures. State the reason for your choice in 6 figures in part A. Okay. Remember, when you're in physics, level 2 physics, and for this standard, and you're trying to round into a specific amount of significant figures, it should always be the lowest amount of significant figures that the question gives you, okay? So for example, it gives you Hannah is 55 kilograms, it gives you the weight 210 newtons, and it also gives you G is 9.8. All of these three measurements are given in 2SF. Meaning that you'll also round your answer to 2SF. So therefore, you're going to be rounding this answer right here. You'll be rounding that to 3SF, and that becomes 390 newtons. One thing I want to get clear here, right? So for example, the question gives you a measurement with 3SF, a measurement with 2SF, and another one with only 1SF. You're actually only going to round it to 1SF, because you're rounding it to the least accurate data. So you're rounding it to the one that has the least amount of significant figures. Not the most, not the one in the middle, but the one that has the least amount of significant figures, okay? Just remember that whenever you're rounding, whenever I ask you to round. So this is actually only an achieved question. Gets you pretty basic, so it's not going to be worth too many marks. But still, it's important to answer in my opinion, it's important to answer every question, as you never know how it could impact your grade, okay? Every little thing counts in my opinion, so that's a thing to keep in mind. Okay. Jess drops vertically onto the other end, causing Hannah to be thrown into the air. When Jess lands on the seesaw, Hannah is thrown into the air at a speed of 15 meters per second and an angle of 70 degrees to the horizontal as shown in the diagram. Calculate the time that Hannah takes to reach the highest point of her trajectory. Okay. So right here, you have a V, which is 15 meters per second in a certain direction. Okay, so what you're trying to see here, so they're asking you, how long will it take for the vertical component of the velocity to reach 0? How long will, because you know the gravity is acting down at 9.8 meters per second, right? So how long will that gravity take to make the vertical velocity 0? Because at the highest point of the flight, the vertical velocity is 0. And then right after that, the object will begin to accelerate back down again, okay? So the important thing to acknowledge is that the question is asking you, how long will it take for the vertical velocity to reach 0 meters per second, okay? That's legit what the question is asking you, okay? Alright, so first of all, you have to find the vertical velocity, okay? So right now you have a V, okay? This is the velocity. You don't want the instantaneous velocity. You want the vertical velocity. So the vertical velocity is just this, the vertical upwards. So that would be V vertical. And then over here, this will be the V horizontal. You have a 90-degree angle here, and you know that this is 70 degrees. Using 90 minus 70, you can figure out that this is 20 degrees. Okay, so then we can join these two and get another triangle here. Okay, so you have here, this is the instantaneous velocity, is this one. And that's V. And that's also the hypotenuse of the triangle. The opposite of 20 degrees is the opposite, which is this side, which is opposite the angle. That's the opposite side. And then the one that's adjacent is over here. That's the adjacent side. So we're trying to find the adjacent side using the hypotenuse. So which so-called Toa is using adjacent and hypotenuse? Yeah, so Ka uses both adjacent and hypotenuse. So we're going to use the cos rule to find the vertical velocity, okay? Alright, so then you have cosine 20 equals to A divided by h, but you know that h is 15 meters per second as given to you by the question, so you can just simply say a divided by 15. You move the 15 to the other side, which means it's now cos 20 divided by 20, not divided, so it's now cos 20 multiplied by 15. So you have cos 20 times 15, and that actually gives you 14.1 meters per second. Okay, so now you know that vertical velocity is, the initial vertical velocity is 14.1 meters per second, okay? It's obviously acting upwards, okay? So the question is asking you, how long will it take for this 14.1 meters per second to reach 0 under the influence of gravity, which is acting downwards at 9.8 meters per second, okay? So in order to do this, we're going to have to be using our kinetic equations. The easiest one, in my opinion, to use would be Vf final velocity equals to initial velocity, Vi, plus acceleration multiplied by time. Okay, because remember, we do not use 15 meters per second in any of these substitutions. 15 meters per second is the instantaneous velocity. We are ignoring the instantaneous velocity. We are trying to find the vertical velocity and how long it will take for the vertical velocity to reach 0. It's important that you substitute it using the vertical velocity, okay? The final velocity of Hannah at the highest point is actually 0, the vertical velocity, since it's no longer moving up, okay? And then Hannah's going to be stopping there for a period of time for like a slight period of time before she begins to accelerate downwards again, okay? And at that height, she's at her highest point, okay? So Vf is 0, okay? So 0 equals to Vi, we calculated, equals 14.1 meters per second. The initial vertical velocity is 14.1 plus AT, okay? But one thing you have to understand here, okay, it's very important. So you have Hannah is moving up at 14.1 meters per second, but then gravity is acting in the opposite direction at 9.8 meters per second, okay? Because it's acting in the opposite direction, okay, it's acting in the opposite direction, that means you have to change the sign, which means it's not plus 9.8 meters per second. That would mean it'll be acting in the same direction. So if you're adding 9.8 t, then then the vertical velocity is going to increase. But when they're acting in opposite directions, they actually try to cancel each other out. So then the vertical velocity will begin to decrease, okay, due to the influence of gravity. And because it's going to decrease, it's actually not plus, it becomes minus 9.8 t. It's important that you remember this, okay? It's crucial, okay? And now the important thing is trying to find the t now. So how long will it take for the vertical velocity to be 0? So let's just say t is 1, right? So 14.1 minus 9.8 times 1, so just be 14.1 minus 9.8. That will still be like 4.3. So basically, like, what you're trying to think here is like, if I lose 9.8 meters per second of speed per second, then how long will it take? Then it'll just be the initial velocity divided by the gravity, and that should give you 1.4 seconds. So basically, it takes 1.4 seconds for the vertical velocity to reach 0, and that's where the highest point of the trajectory is. So if you get to here, you'll get the merit grade, and to get the achieved grade, you simply have to find out the the vertical velocity, which is here. So this is the achieved here. That's achieved. Okay, so obviously you're all aiming for merit, so you obviously don't need the achieved, but I'm going to explain it anyway, okay? When Hannah takes off, the horizontal component of the velocity is 5.1 meters per second. State the size and direction of the velocity at the highest point. So we kind of went over this like a few seconds ago. So when we have the vertical velocity, it's under the influence of gravity, meaning it begins to decrease until it reaches 0. And then after it reaches 0, it's begin to increase in the opposite direction, okay? Because gravity acts downwards, okay? So it says state the size and direction at the highest point. So at the highest point, the vertical velocity is 0, meaning it has no direction because the vertical velocity is 0, okay? And this is because of the influence of gravity that acting downwards and then made the vertical velocity 0. It also tells you that the horizontal component of the velocity is 5.1 meters per second. If they didn't tell you that, then you'll have to go back up and calculate it. So how would you calculate it? So instead of using cosine here, you'll use opposite, which is this one. You'll use opposite and then hypotenuse. Okay, so use sine 20. Okay, instead. Okay, and then you'll find you'll be able to find the Actually, no. You'll be using this one. So you'll be using 70, and then here. This is what we'll be using. So you'll be using 70. This is opposite here. So you'll be using. You'll be using cosine 70. Okay, using the same formula, but using cos 70. Okay. To find the horizontal component. Okay, but right now they've already given you the horizontal component, so that's less work for you. Okay. Okay, so one thing you have to understand is, in level 2 physics and in this standard, the air resistance is considered negligible, which means like we can just ignore the air resistance. Because we're ignoring the air resistance, that means it's like no horizontal forces acting. And because there's no horizontal forces acting, that means that there will be no change of velocity. You know, Newton's first law, it says that the object will remain in the state of motion unless acted by external force. So in this case, there are no external forces, meaning that the object will remain at 5.1 meters per second, okay, for the entire flight, okay? So at the start, it will be 5.1 meters per second, and at the end, it will be 5.1 meters per second, okay? For example, the start was 1 meter per second, the end will also be 1.1 meters per second, okay? It doesn't change, okay? So how are you going to answer this question then? So basically, at the highest point, it will still be 5.1 meters per second, okay? You should get that, okay? So how are you going to answer this question? Okay, so you're going to say the vertical velocity is 0 ms minus 1 at the okay, this is because the gravity gravity acts downwards, which at the highest point makes the vertical velocity 0. So if you're just saying the vertical velocity is 0 meters per second at the highest point, and it's because gravity acts downwards, and at the highest point the vertical velocity is 0. Okay, that's basically what you're saying. Yeah, so because gravity accelerates at 9.8 meters per second downwards, at the top it will be 0 meters per second, and then it will become to accelerate downwards, okay? For the horizontal forces, for the horizontal velocity, there are no horizontal forces acting, and this means that the horizontal component will remain constant, meaning for the entire flight the horizontal component will be 5.1 meters per second to the right. Don't forget the direction, because it asks for the direction as well. So for the entire flight, the horizontal component will be 5.1 meters to the right, and this means that at the highest point, the horizontal velocity is 5.1 meters per second to the right. Okay, now that's pretty much your answer. Okay, it's not too complex. That's basically what you need. Okay, pause the video now, read it. Okay, make sure you understand what I'm talking about. Okay, and this is actually an excellent point. and assuming that you cover everything. So like the gravity acts downwards, the vertical velocity is 0 because the gravity acts downwards, and then how you're saying the horizontal velocity, how there are no forces acting in the horizontal direction, and therefore the horizontal velocity remains constant, meaning the horizontal velocity will always be 5.1 meters per second to the right. Okay, that'll get you excellence. Okay. Okay, for a merit grade, you're going to be saying horizontal velocity is 5.1 meters per second to the right, and you're going to say her vertical velocity is 0. But you don't mention anything about gravity, okay? You have to mention about the gravity as well, okay? That's very important. And to get the achieved grade, your horizontal velocity is 5.1 meters to the right, or her vertical velocity is 0. For achieved, you can have either one of these, and for merit, you have to have both, okay? For merit, you need both of these points, okay? And for excellence, you need to also mention how gravity affects the vertical velocity, okay? Yeah, and that's pretty much it for this question, okay? I'll get into the next question soon. I hope you understand why I went through this question, and if you have any questions, please leave it down in the comments below. Any constructive criticism is welcome, and please leave it in the comments below. Also, please don't forget to like and subscribe for more content. Thank you for watching. See you. Bye.